Yeah, let me introduce the intensity lens from the optical bench point of view, and I will also like to share some of my clinical data. So we work with a lot of companies, including Hanita, when we do studies. These are my financial disclosures. As he already said, it's a great journey we are going through the last, let's say, 20 or 30 years, actually. And at the moment, we have a lot of optical principles, the diffractive technology, refractive, segmental technology, lenses based on spherical aberration, small aperture, wavefront shaping, or high-order asphere, no monofocal plus. So so many different things which are coming up, and it's getting more and more confusing for everybody. And we now have several categories: monofocal plus, EDOF, trifocal. And we can say that the trifocal group is the only homogeneous group because they have really, in most of the cases, they are all diffractive. Sometimes they are hybrid, but in general they are diffractive. So it's a well-defined group. And if you want to do refractive lens exchange, or you want to do cataract surgery and guarantee or promise a patient spectacle independence, there's only the one group of the trifocal IOLs. If you want to do that with the others, you have to do some kind of monovision or whatever, and you cannot really guarantee it. You have the problem of over-promising and under-delivering, and with the trifocal lens, it's just vice versa. The dynamic light utilization technology is a very nice concept for Hanita to introduce a modern trifocal lens. Keep in mind that Panoptix Artelisa 3 is 20 years old technology when it was developed, started in the bench, then went through all the regulatory processes. These are very old lenses, and they are excellent lenses, and they are gold standard, so to say, but at that time, people were not able to get into that detail like you can do nowadays when you develop a new product. And as he already said, what they did is that they collect the light from 5 foci and focus them, so to say, on 3 foci. And as we have these foci of 0 order, 1st order, 2nd, 3rd, and this goes plus and minus. And if you go in one direction, you can overlap the foci and you can lose some light or can reduce the quality. And if you take the intermediate part at the 0 order and then go to the 1st and plus and 1st minus, you can better utilize the light. We use the professional optical bench, these things where all the IOL companies also test and produce their lenses are made in a very elaborative way. And when you test the optical quality, like the modulation transfer function and other things, you use this kind of machinery. And what we now can do is also that we can simulate defocus curves, visual acuity, optical quality on the optical bench. And this is extremely close to the real situation. And we've done a lot of studies actually proving that we can foresee that very well. There are certain conditions where you do that. Important is what kind of cornea module you're using, how much aberration it has, or it's aberration neutral. It's important which kind of wavelight you take, if you take so-called polychromatic normal light, so to say, or specific light. And all of this has been implemented in these studies. We compared here the intensity with the Panoptix Artelisa 3 and the Synergy. And I think most of you know the specifics of these lenses. They're all trifocal lenses. The Technis Synergy is a mixture of the bifocal and the EDOF lens, so bifocal and symphony, so to say. And the others are trifocal lenses or even pentafocal lenses like the Panoptix. The idea was to look for non-inferiority, so that if the lens, the intensity is equal than the others. And you can see already here when we look at the MTF curve, which gives us an idea about the image quality, and you see the curves here at different spatial frequencies, that there's essentially no difference at far, intermediate, and near at a 3 millimeter pupil, so to say. If you go for a 4.5 millimeter pupil, you have the same outcome. Of course, if you have a larger pupil, you have a little bit more distribution. We can also correlate the MTF with the defocus, like you see it here. And as Manfred already pointed out, if you look at the -1 between minus 0.75 to minus 1.25, you see that the green line, the intensity, is way above the other lenses. This can be seen quite nicely here. And then between 2 and 3, they're all the same. And you can also correlate the defocus then with visual acuity and simulate that. And again, you can see here, exactly in the same area, the superiority of the intensity in that specific area. If you look at the distribution, so-called through focus MTF, you can also see that some of these lenses are kind of bifocal, some are more trifocal with different variations, and the green intensity you can see here is very similar to the others. If you look at the resolution, you see here that all these lenses go up to 2.5 to 3 diopters to create a decent kind of focal image. And if you look at the point spec function, then you also see that intensity has a fairly low profile here. There's a difference if you look at polychromatic light versus specific light. Our human eye is emmetropic, so to say, for the green light part. So monochromatic green light, you can see at 546 nanometers, you can see actually a much better performance compared to the polychromatic light. So this type of chromatic aberration, which is also tested here, gives you an idea why you can see pretty good in the intermediate range with the intensity. Now I talk about a little bit the first couple of eyes where we implanted the intensity. You see here the implantation procedure. 7 patients just started with the lens. The very first patient, I used the Huygens formula to calculate it. We ended up slightly hyperopic, so I switched to the Barrett Universal 2, and then we were actually fine and got up very nicely results. The interesting thing is the visual acuity after 3 and 6 months, and then monocular versus binocular. There's a little typo here. The last column is 6 months post-op binocular. And I use the Lockmar scale because it's a standard way we do. And you see we are in all distances around 0 Lockmar. That means 1.0. And also the standard deviation is extremely small. Yeah, so uncorrected distance, uncorrected intermediate, uncorrected near, it's all 1.0, between 0.8 and 1.0. And it becomes even better after 6 months. As you can see there, we reach minus Lockmar data, which means more than 1.0. So we were very happy with these results. And I actually implanted that also in some medical colleagues and 2 friends from my tennis club. And they still talk to me. Then you see the defocus curve. And again, if you see the range here, Lockmar 0.1 is 0.8 in decimal. And you see you have a range here from 1 plus 1 to minus 2.5, almost, yeah, minus 2.75. So 3.75 diopters at this level of 0.1. And actually, for standardization, you take the 0.2 level to look at the focus area, which is here almost 4.5 diopters. So you really get an extremely good visual acuity, in our cases better than 0.8, almost 1.0, over a range of 2 to 3 diopters, as you can see here. This is the uncorrected binocular defocus curve, 3 months. This is the corrected, and there's not much effect because we really landed pretty nice with our IOL calculation and didn't have much residual astigmatism, as you can see, so it's almost identical. Binocularly, you can get a little bit up, as you can see here, and this is after 6 months. Yeah. So if we come to the conclusion, I explained to you that the fact that we have a more or less a flat curve and much better intermediate performance than some of the standard lenses could be seen in the lab, and as Manfred also pointed out, could be seen in the clinic, especially also in our patients. We have excellent defocus curve and visual acuity from at least 0.1 Lockmar or better through a wide range of dioptric power. And we think this is a very good and modern lens. Much better than lenses that have been developed 20 years ago. And I think we will see much more of these type of lenses. Also interesting was the very fast neuroadaptation in this process. And I think better light distribution is some of the part that may also contribute to that. So thank you very much, and I'm very happy to answer any question.